Forest ecosystems are incredibly complex. Each is a unique combination of biotic and abiotic processes and components interacting with one another. In complex systems, however, it can sometimes be useful for us to try to establish or develop simplified models to help us understand the processes that are going on in that system. In 1990, Oliver and Larson proposed a four-stage model of forest stand development, and this model has been widely used. It does a reasonably good job of explaining how forest stands develop over time. The first stage in this model is stand initiation. This stage begins with a severe stand-initiating disturbance that kills all mature trees, though it may not kill all understory vegetation or advanced regeneration. After the disturbance, early successional species colonize the site through seeds and propagules that were already present on the site or that come in from elsewhere via wind or water or animals. During this time, there's very little competition for resources. There's lots of resource availability, especially light. So this is a period of incredibly fast growth and change over time. As long as there is still available growing space, new individuals and even new species of trees or other plants will continue to arrive and fill in that available space until it is gone. This stand is in the initiation stage, but it is a managed stand, so these processes haven't happened naturally. This stand was harvested as a clear cut with group retention. There are a few areas where groups of trees were left behind unharvested. And the tree establishment has been by planting, by hand planting. As I look around, I see a fair number of healthy looking Douglas fir, western red cedar, and western white pine. They were planted about 5 years ago. And there's also a little bit of western hemlock regeneration. There's lots of seed source around for western hemlock, and it regenerates very well without human intervention. So that's why no western hemlock have been planted here, but they will be a component of this stand in the future. The key processes of this stage are the stand initiating disturbance, followed by tree establishment. The key structures include a rapid accumulation of biomass, and a lot of this is in the form of very brushy vegetation, as well as continual arrival of new individuals until that space is fully occupied. The second stage of the four-stage model is stem exclusion. Following the stand initiation phase, plants, and I'm going to focus on trees here, have fully occupied all of the available growing space. So during this stage, no new tree establishment takes place. The foliage layer rises and the canopy closes. At this point, light becomes a really important limiting factor because we have the same number of trees that we had at the end of that stand initiation phase, but now those trees are growing, so they're taking up more space. So there's really fierce competition for resources, especially light. The name stem exclusion has two meanings in this case. The first is that new stems or new trees are excluded from establishing in the stand. And the second is that some of those less vigorous stems will be overtopped and killed, thus excluded from the stand. We expect to see some density-dependent mortality during this stage. That means the mortality is related to the density of trees. Higher density, a greater likelihood of mortality. In this case, slower growing, shorter, less vigorous trees might be overtopped by faster growing, more vigorous trees. So those smaller trees don't get enough light, and they may not get enough light to survive, and they may die. This process is also sometimes called self-thinning, because some of the less vigorous trees will die, leaving more resources available for the more vigorous trees. The dense canopy in this stage prevents much light from reaching the forest floor, so typically there is minimal understory vegetation, including shade-tolerant species. The stand that I'm in right now is in the early stages of stem exclusion. There's a very dense canopy of small-crowned trees. The forest floor is pretty bare of vegetation. And there's a little bit of density-dependent mortality, but not a lot. There are definitely some smaller trees that have clearly been overtopped by other trees and died from resource limitation, but there hasn't been a lot of that. The reason for that is this is a managed stand, and it was planted about 35 years ago. When a forest is planted, the number of trees per hectare planted and the spacing is based on two competing objectives. The first is to have enough trees at high enough density that those trees will be able to outcompete other vegetation that might come into the stand naturally. But the second is to have few enough trees that those trees will be able to give each other enough space so that there won't be significant density-dependent mortality. This stand is kind of right on that line. However, as these trees continue to grow and compete more for limited light and space, there will be increasing self-thinning. So in a managed stand like this, what will typically happen, and it's going to happen in this stand, is there will be a thinning. So prior to much density-dependent mortality or self-thinning happening, a harvest will take place. Typically, the less vigorous, smaller trees will be marked for harvest. They will be removed, so they'll be removed before they died of natural causes so that some of that revenue can be captured. And then that will leave more resource availability for the remaining trees, so they'll be able to get a burst of growth and grow into higher quality trees. The key processes during the stem exclusion phase are density-dependent mortality, resource limitation, intense competition, and vertical stratification. The key structures are a dense, single cohort canopy composed of small crowns. The next stage in the four-stage model of stand development is understory reinitiation. In this stage, the stand continues to grow and develop, but now a new understory will begin to establish made of shade-tolerant herbs, shrubs, and/or trees. There isn't a lot of light available at this point, so this understory will be relatively slow-growing. However, there may be some small disturbances that create gaps in the canopy, allowing more light in certain areas, and so in those areas, that shade-tolerant understory will grow more quickly. This stand here that I'm in is a little bit artificial because this is a managed stand, and it has been thinned recently, so some of the trees from the overstory have been harvested to reduce competition for the remaining trees. As a side effect of that, more light is coming down to the understory. So that's why we're seeing a really robust layer of regeneration of western hemlock. If this were an unmanaged stand, we probably wouldn't be seeing quite as much understory development as we are here, and it would probably be happening a bit later in the timeline of that stand. Key processes in this stage are canopy structure differentiation. We're going to start to see more of those typical layers in the canopy. We'll see density-independent mortality, so there still will be some scattered mortality in the stand, but it's not going to be so strongly related to competition between adjacent trees. And lastly, the establishment of a new cohort. Key structures in this stage are larger crowns for the canopy trees and the establishment of an understory layer. And finally, the last stage in the four-stage model of stand development is old growth. Eventually, given time, a forest stand may reach the old growth stage. As trees in the overstory die from old age or from small patchy disturbances like insects or disease, gaps open up in the canopy, allowing light down into the understory. This light can allow understory species, especially shade-tolerant species, to grow up into the canopy. So over time, those shade-tolerant species, especially those that established during or after the understory reinitiation phase, will move up into the canopy. So eventually you'll have a forest where the canopy is entirely made up of long-lived, shade-tolerant species. Eventually these processes result in an uneven age stand, one that has a high diversity of ages of trees, as well as high structural diversity in the vertical and horizontal directions of the canopy. For more information about old growth forests, see the videos linked in the description. The key processes in this stage are gap dynamics and death due to senescence or fine-scale disturbance. The key structures in this stage are multiple age cohorts, large, widely spaced trees, large dead snags and coarse woody debris, a multi-layer canopy, and a structurally complex stand. For a quick review, the four stages in this model of stand development are stand initiation, where a stand initiating disturbance kills all mature trees, and this is followed by the establishment of new trees. Stem exclusion, where growing trees fiercely compete for limited resources, especially light, and density-dependent mortality is one of the results. Understory reinitiation, where a new cohort of shade-tolerant herbs, shrubs, and trees establishes. And old growth, where gap dynamics lead to an uneven age stand with large, widely spaced trees, multiple age cohorts, and complex vertical and horizontal structure.